Hello everyone, welcome back to my YouTube channel Nursing with Beatrice. In today's video, I'll be looking at intravenous fluid calculation. So this will be in ml per hour and gtt per minute. So this is part of the dosage calculation series. I've done other videos, you want to check them out. So at the end of this video, you should know how to calculate IV flow rate in ml per hour. And also you should know how to calculate IV flow rate in drops per minute. That's what we call GTT per minute. And then you should be able to identify the two kinds of tubings. We have macrotubings and microtubings. So just to touch on this, so calculating IV flow rate in ml per hour. So this one is done when you are using an IV pump, an infusion pump. Then for drops per minute, when you as a nurse, you are manually operating it, you are trying to calculate the drops that will enter the drop chamber. So you'll be making use of drops per minute, which we also call GTT per minute. Now, also to identify the two kinds of tubings, we have what we call macrotubings and microtubings. So the macrotubings has to do with the bigger, larger tubings. Now the drop factor for this can be 10, it can be 15, it can be 20. There are other variations depending on solution, but these are the most common macro tubings drop factors. Then we have the micro tubings. So the drop factor for this is 60. This one is commonly used for pediatrics and for older adults, just to regulate. So what it means, let's give example. When we say 10 GTT per mil, which is the drop factor, what it will mean is that about 10 drops of the fluid will enter the drop chamber to equal 1 mil. So that's like 10 drops equal 1 mil. If you say 60 GTT per mil, what we also mean is that about 60 drops entering the drop chamber will equal 1 mil of the solution. So we're going to look at examples. So the first one is going to be on calculating flow rates. So how do we calculate flow rate in mil per hour? So this one will be centered on using a pump. While this other one, calculating flow rate in GTT per minute, like I said, will be centered on you manually as nurse. You are manually regulating the drip. Okay, so let's look at example 1. It says 1,500 mil of D5W over 12 hours. We are asked to calculate the flow rate in mil per hour. The formula we use is flow rate, which is in mil per hour, equals the amount of the solution or amount of the fluid, amount in mil, divided by the time in hour. This is the formula we use. So if we look at this now, so the flow rate for this one now, the amount from the question, it says 1,500 mil. That would be the amount or the volume. The time, it says over 12 hours. So we put 12. So if we divide this will give us about 125 mil per hour. So what that means is that we're going to set the IV pump to regulate at 125 mil in 1 hour. So that will be the answer for the first example. So let's look at question 2. So the question 2 says, a client on an infusion pump is to receive an antibiotics in 100 mil of 0.9% normal saline over 30 minutes. So we're working with 100 mil as the amount of volume, and the time is saying 30 minutes. So let's put it into the formula. So if we're using the same formula, the volume is 100 mil. We're calculating the flow rate. So flow rate, let's say it's X in mil per hour. 100 mil over time. So the time says 30 minutes, but remember our answer must end in hour. So if we say 30 minutes, this is mil, times, now how many minutes makes an hour? 60 minutes. So we can say times 60 minutes over 1 hour. The logic here is, So that if minutes cancel minutes, we'll be left with meal per hour, which is back to our formula. So 30 and 60 will have 2. 100 times 2, that will give us 200 meal per hour. 200 meal per hour. That will be our answer for this. So let's look at example 3. So the question says 100 ml of 0.45% normal saline in 45 minutes. So it's still going to be the same principle. So 100 ml, the time says 45 minutes, but we need it in hours. So multiply by 60 minutes per hour, per 1 hour. So this will cancel this. So 15 here will give us 4, 15 here will give us 3. This time this will give us about 133.33 up to infinity. So we are going to approximate this to 133 ml per hour. This is because this is not up to 5 and the infusion pump cannot deliver half drop, so you must round up to a whole number. So this will be the answer for the third example. Now let's look at how to calculate flow rates in gtt per minute. That's in drops per minute when you are manually regulating it as a nurse. So the first question says D5W to infuse at 100 ml per hour. Take note of this, 100 ml per hour, and the drop factor is 15 GTT per ml. Don't confuse this. We are looking for the answer in GTT per minute, the flow rate, drops per minute. But drop factor is always GTT per ml, talking about how many drops will be in the chamber. To solve this, we are going to use a formula that says the flow rate, just slightly different from the other one, flow rate, this time around in GTT per minute, equals to the volume or the amount of solution in ml times the drop factor divided by the drop factor is in GTT per ml divided by the time. This time around the time is in minutes. In minutes. So if we put into the formula for question 1, our x in GTT per minute, which is drops per minute, equals to the volume says 100 ml. So we say 100 ml per hour. So per hour means per 1 hour. So 1 hour, but we're looking for this in minutes. So we just say 1 times 60 minutes. 100 ml times the drop factor. According to the question, our drop factor is 15 GTT per ml. So don't get confused how I got this. We know that 60 minutes make 1 hour. So that's why I'm multiplying this by 60. So if we do this, 15 here, 1, 15 here, 4. So 4 divided by 100, we'll be having 25. So our S will be, because we're looking for it in GTT per minute, will be 25 GTT per minute. So this will be our flow rate in GTT per minute. Let's look at question 2. So question 2 says 1 liter of 0.9% normal saline in 10 hours. Drop factor is 20 GTT per ml. We have to calculate in GTT per minute. So our X, based on our formula in GTT per minute, equals to the volume. The volume is supposed to be in mil, but we're given in liters. So 1,000, we know that 1,000 mil is 1 liter. So we'll be putting 1,000 in place of 1 liter. 1,000. All over the time. The time we're given is 10 hours, but we need it in minutes. So we'll be multiplying 10 by 60 minutes. because 60 minutes make 1 hour times the drop factor. Our drop factor is 20. In case you are still confused how I got this, so just use like a proportion ratio. We know that 60 minutes is equals to 1 hour. So if we have 10 hours and we're looking for it in x minutes, if we cross multiply, so our x minutes will give us 10 times 60. 10 times 60. So that's how I got this. So if we cross this out, 20 here, 20 and 60, we have 3. 10, we cancel this, so we have left with 100 divided by 3. So this will give us 33.33. So approximately, because it can't deliver half drop, so that will be approximately 33 gtt per minute. So that will be the answer per minute. That will be the answer for number 2. Now let's look at question 3. So question 3 says an IV medication in 50 ml of normal saline in 15 minutes. Drop factor is 60. Our X again in GTT, in drops per minute, equals to the volume. It says 50 times the drop factor says 60, and the time says 15 minutes. 15. So for this one, we're not going to convert because it's already in minutes. So we'll just go ahead and divide. 15 here, 1. 15 here, we have 4. 50 times 4, we have 200. So our answer will be 200 gtt per minute. This will be our final answer. So that wraps us today's topic on IV fluid calculation, particularly in ml per hour and in GTT per minute. If you find this video helpful, please like, share and subscribe for more educational videos. Thanks for watching.